Okay, welcome to Rigid Motions packet number 4. We're jumping right to number 4, and this will kind of segue into what we call proofs. And having done this packet will really prepare us for what is about to come in the proofs unit. So today is Monday, 11/2. Happy November. Congruence using rigid motion. So we talk a lot about congruence for several months, and then we talk a lot about similarity for some time after that. Congruence is when angle and distance are both the same. In other words, rigid motions. We talked about that term a lot. Rigid motions is when you have an isometric transformation, which means both angle and distance are preserved, also known as the process of being identical. So remember, rigid motions, reflections, rotations, translations, because distance and angle measure are preserved. So here's a congruent statement. We read that as quadrilateral ABCD is congruent to quadrilateral MNOP. And the congruent symbol, which is this right here, is really made up of two symbols. It's got an equal sign, which means equality, right? Which means it's the same measure, same size. And then it has the wiggle at the top, which means similarity, which basically means the angles are the same, which gives it the same shape. So when you have the same size and same shape, you are congruent. So we're going to be writing this notation a lot. An equal sign with a wiggle over it, and it means congruent. So quadrilateral ABCD and quadrilateral MNOP. I'm just going to draw a random quadrilateral, and a quadrilateral just means it has to have 4 sides. Nothing more specific than that. And I'll draw another one. So take a minute to draw, as best you can, 2 identical 4-sided shapes. I'm going to label this one A, B, C, and D. Notice I did that in the same colors as the letters were up here. And then I'm going to do the same thing here. M, N is red, blue is O, and green is P. Different green. Green is P. So the reason, and we don't write them in colors all the time, just as a good way to introduce it, the reason we did that is because I want you to see that A is related to M, and B is related to N, and C would be related to O, and obviously D is related to P. So if those angles all match up, then those angles are congruent, because it all has to do with, down the road, mapping one onto the other, which this will obviously do, and the colors all match up. So if A maps onto M, B maps onto N, C maps onto O, D maps onto P. If that's true, then this side maps onto this side, and this side matches up with this side, and this, and this, and that, and that. So here it says list all the corresponding parts. There are 8 parts going on here. You have 4 angles and 4 sides. So first let's just do angles since it's easier. Angle A is going to match up with and be congruent to angle M, right? That's its twin on the other one. And then we have angle B is congruent to angle N. And then we have angle C being congruent to angle O. And you probably guessed it, angle D is congruent to angle P. So there's 4 corresponding sets as far as angles, but then I also have 4 corresponding sides. So that looks like this. AB is congruent to M, and we make a little segment notation over each one. Segment AB is congruent to segment MN. So what does that really mean? Segment AB is congruent to segment MN. So 2 letters make up a segment, start and finish. And then I have segment BC being congruent to segment NO. Right, so I have BC and NO are congruent. And then we're going to start with C and go the other way. CD is congruent to OP. Right, because the top here, this side and this side are congruent. They map onto each other. They are identical twins. And then to bring it back to the beginning, you can say AD is congruent to MP. And of course, we're talking about that side and that side. So these are all the corresponding parts right here. There's 4 angles and 4 sides in a quadrilateral. And those are the ones that match up with the twins on the other side. 4 angles are congruent to 4 angles, and 4 sides are congruent to 4 sides. The key word there is corresponding, which means, we know that from angles, it's in the same position, right? So angle A corresponds with angle M, right? Angle B would correspond with angle N. Correspond is the same position on the other shape. This corresponds with this. So what does this statement mean? It's a 5-letter acronym, CPCFC. And it won't be long that we're going to change that to CPCTC, but that's just a sneak preview. That stands for corresponding parts, meaning parts in one triangle that are the same as the other, of congruent figures are congruent. So CPCFC, corresponding parts of congruent figures are congruent. And it's almost common sense, right? So if I said A corresponds with what? Well, A's twin over here is M. These correspond. So if these 2 figures are congruent, which it told us they were originally, that means all the corresponding parts are congruent. So if you had 2 identical cars, the left driver door of one car would be congruent to the left driver door of the other car, if they were 2 identical cars to begin with. All the parts have to be congruent if the wholes are congruent. That's what this means. So corresponding parts of congruent figures are congruent. All right, what rigid motion would map the yellow one onto the green one? If I was going to, let's say, use patty paper or tracing paper, or just visualize this, how could I get this one onto this one? What rigid motion was that? Or that? All I did was slide it, right? I didn't do any turning, I didn't do any rotating, I didn't do any dilating, which isn't a rigid motion anyway. I didn't do any reflecting. All I did was slide it over. So if you translate, how far did we go? Let's see, we took Q and went 1, 2, 3, 4, 5, 6, and down 1, 2, 3. So we translated to the right 6, down 3. That was the rigid motion that mapped one onto the other. So then what's the congruent statement? That means that something is going to be congruent to something else. So I'll call this one QRST. Remember, you have to name it in a circle. It doesn't matter if you started with R, as long as you go around the track in a circle. But if I started with Q, you would imagine you'd have to start with U. U, V, W, X. The order matters, right? Once you've chosen this order, you have to follow it with this order. So if you notice, Q corresponds with U, R corresponds with V, S corresponds with W, and T is in the same position, corresponds with X. So now what are the corresponding parts? There's our 4 corresponding sets of angles that we just talked about. And now there's 4 corresponding sets of sides as well. For example, QR and UV. So QR is congruent to UV. And then we have RS and VW. RS is congruent to VW. And don't forget our little bar over the top meaning segment. And we'll talk about when you don't use that another time. And then if we go through the bottom here, ST, WX. ST is congruent to WX. And then to bring it back to the beginning, QT and UX. And people often ask, can you say it in reverse? Could you say TQ or XU? Yes, you could, but just keep the order that you like to, because it's almost like the commutative property. QT and TQ are the same distance, same piece. Example 2, what rigid motion maps these two? Let's take the yellow one and try to go to the blue one again. Looks to me, you could already see I put the crosshairs on the origin. If I rotate it just like that, with one click to the right, which was -90, clockwise is -90. So I rotated around the origin -90 degrees. That's how I got one onto the other. What's the congruent statement? QRST is congruent to U, because that was the pointy part. And then the inner part was V, and then I went to W, and finally to X. So order matters. Corresponding parts. First two, angle Q is congruent to angle U, angle R, and angle V. And you might be looking at the picture, but here's a shortcut. You could do it by just looking at the statement here. The third one is S, the third one is W. Angle S, angle W. The fourth one is T, the fourth one is X. Angle T, angle X. The same thing with sides, right? The first two are congruent to the first two. The second and third letters are congruent to the second and third letters. The third and fourth letters are congruent to the third and fourth letters. Fourth back to the first, TQ, and then the fourth back to the first, XU. There's all your corresponding sides. Tell us on this next one, which rigid motion maps this one onto this one? And is it reflection, rotation, translation? And if it's one of those things, what are you doing that over? You're going to write that right here. Then you're going to write the congruence statement. What is congruent to what? We won't worry about the corresponding parts for this one. That was your intro to congruence using rigid motions.